Hey everyone, you're watching the Inside Out BIM, and today we're continuing our series on Revit API, in this case having a look at points and vectors. Actually, in Revit API, it's one object, it's called XYZ. If you haven't watched the previous parts, make sure to do that because that is a follow-up video. For example, from the previous video, we're going to be using the method pick elements. That is the extension method for UI document class that we've created. Before getting started, if you find the content useful, please like this video, subscribe to the channel, leave some comments, and turn on notifications. So let's get started. So first of all, let's kind of go to like Revit API. Yeah, so that is some links for you from the previous video. So here, let's go to API again. Sorry for the background, so it's just for my eyes, but I hope you're confident with this one, with the background that I have right now. So what I'm gonna do here is that just gonna look for the XYZ class and just kind of read about this. So what it is. So the question on what it is, you can find it here in the description. So it's an object representing coordinates in 3D dimensional space. And basically, when you think, like, especially people who came from Dynamo, in Dynamo we have points and we have vectors, but in Revit API it's one object. And let's kind of think, why is that? Let's even go to Revit first of all and kind of like just go through elements and think about what happened there. For the time being, this link instance, I'm gonna move it there. So each element that we built in Revit is built based on either a point or a curve, right? So we have point-based elements and curve-based elements. For example, this element that we've placed here, this table, if I go to snip current selection and I want to analyze it, each element has a property called location, which gives you a location point in this situation. And here, out of the location point, we can grab a point by putting by like grabbing the property point, right? Let's kind of do this in documentation. So do pretty much the same thing. So I'm gonna go to element class. I'm gonna go to properties, element properties, and I'm gonna find the location. As you can see, it returns the location, but here we have a location point. So if you scroll through location and if we check the hierarchy, we see that location is at the highest level. Like, we're not talking about API object just, but it's like, I think that is like the base element for all. But we have location and two classes that inherit from location. We have location curve and location point. And this is what I was talking about, that actually if we have point-based elements and we have curve-based elements. Let's look at the location point, because location point is a location. You remember, right? Like the hierarchy with inheritance and how that works. And here, oops, we can go to properties and here we have a point. Even though that's called a point, you see that it returns the XYZ. So this is what you need to know about. So that is XYZ. Also, like the wall, it has a curve. Now we're not going to check it out. In the next video, we're going to see how to change element location. For the time being, we're thinking about vectors and points. And in Revit API, again, it's just an XYZ. And why it's so easy to visualize everything in Dynamo, and that is the reason for this, because we can visualize it. We can easily place it and see this. So I think that the best way to actually master geometry via API is to learn how to visualize each element, because that is the problem that we have, is that via API we cannot actually that easily visualize elements as we do in Dynamo. So right now, again, we're going to talk about geometry more, but I just want to show you how to visualize elements. So here we're going to have a direct shape class, because right now I want to show you the point and where it's placed, right? So I want to go with the direct shape. And here we can create this direct shape. What is a direct shape? That is the class used to store externally created geometric shapes. I think it's all the export geometry that you have, right? So as you can see, primarily intended use is for importing shapes from other data formats such as IFC or STAB, right? So stuff like this. And actually, for the time being, we're going to work with direct shape more in the future. For the time being, it's just for us to understand how that can be generated. So here, if I go to uh, elements, I have the static method to create this element, right? So let's kind of see how that can be generated. So let's kind of open up, oops, direct shape. There we go, create element. So we need to create a direct shape. We put a document and we put an element ID. As you can see, it's a category ID. And then we need to use the set shape. Let's just create a simple one. So let's actually create a point there. So let's see how we can create a point. So let's go to XYZ class and let's go and see we have a constructor. We have a simple constructor like without any parameters. So that is called parameterless constructor. And that creates a default XYZ with value 000. Let's create something like this. So what I do here is that I'm going to open up my Visual Studio, and what I'm going to do here for the time being, I'm going to comment this out. I don't need these selected elements. I'm going to go just point, and I'm going to go new XYZ, and like that. So we can create this without any constructor. And I want to create a direct shape. So I'm going to go var direct shape, and I'm going to go direct shape, create element, and here I need to pass a document and element ID. So I'm going to go new element ID and built-in category, and let's go with the OST generic model. And I want to, and to actually have this one in your model, right, in Revit document, if I go here, you need to use set shape. So set shape, for example, this one, it actually builds the shape of this object from the supplied collection of geometry objects, right? These objects are copied. To put it simply, it's just going to create this in the document. So I'm going to go with this overload. There are two more, but I'm going to go with this one. And we need to pass a list of geometry object. And right away, what you may think is, what the hell is a geometry object? And actually, it's a very abstract, like geometry object. It can be pretty much anything. And that is true. Geometry object, that is like a base class for all geometries. And here, as you can see, that is the main class, and curve inherits from this, edge inherits from this, face inherits from this, point inherits from this, right? All of this stuff. But you may notice that we have a point, but not actually an XYZ, and that is right. Point and XYZ in Revit API is different. To be honest, I only use points for visualizing. Sometimes we get sometimes we get points from something, but I usually deal with XYZ. And actually your point, if you go to properties, it has a property called coord, and that will give you XYZ. So that is just some like, so make sure that XYZ is not a geometry object. So if you go to XYZ and check at the hierarchy, it actually doesn't have that much of a hierarchy. So we need to have a point of this. And how to create a point based on the XYZ is that here we have a method create where we simply pass XYZ. It's not that difficult. So let's gonna do this. So, and to set shape, we need to do this within a transaction, right? Because, right, transaction, new, new transaction. As you remember from previous videos, please check them out when we talked about transactions. So whenever you make some changes in Revit document, you need to do this in transactions because that is the same way as as you can see, these are all your transactions. So if you create a new instance like this, so let's gonna create a new instance, place a new instance. It's gonna have a transaction called component. So right now we're gonna go document and put a name, create points, for example. I'm gonna go transaction start, transaction commit. And actually, we're going to talk about all of the transactions options later on because we have a rollback here and other cool stuff, but we're going to talk about them later on. So here, what I'm going to do is that I'm going to go direct shape, set shape, and here I need to pass a list of geometry objects. And I'm going to go new, list of geometry objects, and I'm going to pass here point dot create this point that I've created, like that. Let's see if we will have something. So let's gonna compile this, Control Shift B. I'm gonna go to my project, actually go to first level, and let's find the origin. That is the origin. Let's mark the origin with reference planes. So it's gonna be easier for us to see what is going on here. And let's gonna run this. So I'm gonna go main, run, okay, modification outside transaction. So basically we need to create it also inside a transaction. So I forgot to do this. So what it's telling us that this part should be also here. Yeah, I kind of made a mistake. So it should be within a transaction. So now if I go and create it, it will create a point here. So as you can see, direct shape is just like some shapes that we can place in Revit. And actually, that is where how I usually visualize things in Revit. So it's easier for me to understand them. And now that is the way that we're gonna actually master vectors and points. So for the time being, what I want to do, and actually right away, so let's kind of create this quickly. So usually you want to visualize this really quickly. So what I want to do, I want to add an extension method for my document where I can just go document, create direct shape, and just put a list of geometry objects in there. Isn't that would be cool, right? So let's create something like this. So here we have extensions, and I'm gonna put this in this folder. Later on, we can organize this with different folders. So I'm gonna click Control Shift A, or you can go right click, add item, and select a class. And here I'm gonna have something like document extensions, right? And again, if you remember, the syntax is going to be public static class, public static, and we're going to say what we want to return. And we want to return, let's go with the, let's see what we want to like set shape. If you go with var a like quickly, I think it returns void, right? So it returns void, right? So that part returns void. Maybe we want to have like direct shape. So let's say that I want to return, actually it's not something I want. So here I'm going to say that I want to return direct shape. As you can see, the ReSharper tells me that I need to have this namespace to have direct shape. So once I click it, it's going to do this for me. So this is why you need to use ReSharper. So I'm going to go create direct shape. And I want to use this. If you forgot what it is, it's actually extension methods allow us to add new methods to the existing classes that we don't have access to. So I don't have access to the document class, so I'm creating an extension for this. Document doc, and I want to put right so what I need to have here is the list of these geometry objects. So I'm gonna have here like list of geometry object, right? Geometry objects, and I want to also have like usually I want to pass like mm, some some of the built-in category, right? Because here we're saying what is the category. So it's not a big deal to just go there and say like um, element ID and say oops, and that will be category ID, and let's put a default value for this new element ID built-in category OST generic model. And here, actually, a default parameter, it can only be initialized with null, right? So now it's telling us that we can actually only say that that should be something like this. It cannot have a default value over here. But we can actually do something here. So we can say that if you remember, like we used it somewhere like with the selection extensions, if you remember, when we type like if element null, just do something. So we can go like this, category ID. So how you can do this, right? In a silly way, you can go if category ID equals to null, right? If that equals to null, you can say category ID should equal to new element ID built-in category generic model like this. But also you can do and type it like this, category ID, and that should be new element ID built-in category always T generic model, and that'll be like perfectly the same part. So if that is null, that will assign this, right? So that is like the power of this. So I can say set it here, and I'm gonna say um, var direct shape. So I'm gonna quickly create it. Direct shape. Actually, it would be better to copy, but I can do this quickly. Copy category ID, and I can go direct shape, set shape, and I want to pass like geometry objects there, and I want to return this direct shape. Let's document this right away. So this method is used to create direct direct shapes doc in a document. Also, you can describe what each parameter means. For example, like current document, right? Current document, geometry elements, and category category ID. Let's put this with this like that. So what now we can do here is that instead of doing all of these things right now, I can simply go and use document, create, create direct shape, and I simply need to pass this new list of geometry objects, and I can go point dot create point, and that's it, right? So now, and if I want, right, I'm just going to show you again the power of this extension methods. So now if I run this, I'm going to get the point. If I decided to change the, uh, like, if I said that I want to have new element ID and I want to say a different built-in category, for example, like furniture, right? It's not going to be a big deal for me to go there. And now when I create it, I will actually see that that point is of category furniture. So just how we quickly set that up. It's not that complicated at all. Also, you can actually here, if you want, you can say built-in category and just create an instance of this here. So maybe it's even would be better, right? To go like built-in category. I think it IntelliSense for some reason doesn't find it, and I'm gonna go like built-in category, right? So here I'm gonna say if that is null, if built-in category equals to null, I wanna actually grab. So what I need to have here is that I actually can go like this, right? Like this, because built-in category, or maybe we can actually pass like built-in category. Let's go with this one. And I think we can actually say built-in category OST generic model. Oh yeah, we can do this that way. It's even better in that situation, right? I think the name is okay, yeah. So now it's even better. So that is gonna have a default value, and we don't even need to have this. We just need to go like that to go new element ID and put this built-in category. Yeah, it's even better like this. So now it's gonna be built-in category actually. Built in category, and let's have and put it here for the comments. Actually, it takes some time to document everything, but I want to show you how that is being done. So now let's think about how we can like why x, y, z and vector are the same actually, why that happens. Now we just know at least how to visualize this, but now let's understand what are the characteristics, what is the information of the vector that we usually have. And vector, why it's represented by only one point, because it always starts from the beginning of the coordinate system. What do I mean by that? If I go to 3D in Revit, even or like 2D, it doesn't matter, and I go to visibility graphics, here I'm going to go to site and I'm going to find the internal origin. So this internal origin gives me this coordinate system, and that is something that is immutable. That means you cannot change it. So basically here, you cannot see this, but let's kind of also have it in this plan, like internal origin. So it's going to be here. So that is like global coordinate system. And what vector represents, actually the main characteristics of the vector is its point, right? It has a point and it has a length. And you may think, I always thought of vector as a line. And actually it's okay because we can represent this as that, right? So that can be our line and we can say that that is like a vector. So we can make this interpretation because what usually happens, let's put a component here, right? So here we have an element here. And if you want to move it here, this is the point. So let me kind of copy this like here, like that. And we want to move it. And I go move from here to here. But the vector, the point will be just here because that is the vector. So from current and go to this direction. Let me kind of show you step by step how that happens. So first of all, again, what I want to do is that I want to kind of switch to the documentation, read, show you what that means, and all of this stuff, because that is vitally important for you. Let's see the methods that we have. And actually, we have a lot of them. We can add, we can go angle on plane 2, angle 2, actually a lot of stuff. And actually, almost all of them are related to vectors, not that much to points. So actually, all of these methods, this is for our vectors, not for points, right? So here, the main idea is that we have a length of the vector. So we can actually, if I go to properties, I can grab its length, or we have this in the method. Yeah, method, get length. There we go. We have get length method, and we can normalize it, meaning we can make our vector length equal to 1. And actually, without this talking, it's better to kind of show this right away and kind of, so you can understand. So let's create a point with coordinates. Let's go 1 on x, 0, 1.5 on the y, and 0 on z direction. And I'm going to create it. Actually, right away, what is the problem that we have? I think it's vitally important for us to always visualize it. So now we have a point, but let's kind of visualize it with a line. Isn't that would be cool to visualize it as a line? So what we can also do here to visualize it, and I know that it can take quite a while, but I really want to show you how to create all of these extension methods and how to actually work with this. So I'm going to create a new class, and I'm going to name this XYZ extensions. And here I'm going to go public static, and I'm going to name this first of all like public. Let's even go with void because I just want to visualize this, or let's even return line. Okay, but and it again, it's gonna import it for me line visualize as line, right? As line, and I can say this XYZ point, right? But public static. Don't forget to make it static. And I want to visualize it, and I definitely want to say what is the document I want to have here. Document. What I'm going to do here is that, because that is my, actually not a point, let's name this correctly. That is a vector. And how we could visualize that is that in Revit API, we have this element called line, and we can create bound. Create bound means that we're going to have a line that has an start and end. Create unbound, that means that it doesn't have an end. So we go create bound, and we're gonna say my beginning point. And actually, if you go again to documentation, make sure you go through this. You can see that in your properties, you have zero property, and that is a static property. That means that we don't need to create an instance of XYZ to get this property. And that gives us the coordinate origin or zero vector. So what I do here is that I go XYZ 0, and that will be my start point and my end point, right? I want this part to be vector, right? So that is going to be my, it's like end point of this vector, and that will be representation. But actually, sometimes you want to kind of like, and that can work in this specific situation, but what if sometimes we would like to change the origin for this and visualize it from some different place? And we're gonna go back to this and make it better, right? I'm gonna return this, not return, but let's go var line, and I'm gonna visualize this. Like I'm gonna go document, create direct shape, new list, and I'm gonna pass this line, and I'm gonna return the line. We're going to go back to this and we're going to refactor this later on because we would want to add more functionality to this, but not for the time being. So now what I want to do is that now I can simply go, I can have the point and I can have visualize this line and pass just to document. So isn't that cool that we can actually use this that way? Also, we can click, go with the Control RR and name this vector, right? So let's kind of visualize it. So I'm going to go main, and that is our vector right now. So that is how our vector represents. And what I want is that, to make it kind of more visible, let's kind of move this furniture, for example. Now we're going to select it and move this. What is responsible for movement is that here we have a class, element, element transformation utils, and here we have like methods for movement of elements, right? So here we are actually moving elements. So let's do this. So what I'm gonna do is that I'm gonna use previous function like this, select elements, and I'm gonna select elements that are family instance, and I'm gonna pick element from the current document. And I wanna select the first one right away because I know that I'm gonna select only the first one. So now I have element. And what I wanna do here is that I'm gonna go element transformation utils because it's like it has like these static methods. We have move element, we specify the document, we specify element to move, we go selected, let's rename this like selected element, and we're gonna go selected element ID because we need to pass an ID, and here we're telling where to move, and here we're actually passing the vector. Well, let's kind of grab it here. Right, so now let's kind of try to do this. I'm gonna run this. It's gonna prompt me to select element. I'm gonna select it, call finish, and now it was moved. As you saw, it was moved at this distance, right? Because this is how that works, right? So it kind of, if I grab the center of this, right? So I grab the center of this. If I copy this portion here, and I'm copy, let's grab the end, let's grab it there. And if I kind of move from the center back here, that is going to be exactly where it was before. So the first lesson that you need to learn and understand is that vectors, why they have only 1 point and it's not actually 2 points, because it always has a zero, it always has the origin. Like the first point is going to be the origin of your global coordinate system. So that is always going to be the start, right? And you're just defining here, like I want to move here, here. So basically, as you can see, and it just goes and move that element some like from the center and goes where it needs to be. So basically, this is the way it works. And that is just some simple manipulations. Now, so the first lesson is that our vector y, it has only a point. It's only one like x, y, z, because the beginning always goes from the from the origin of our global coordinate system. Now the second part, uh, what I would like to see. Also, let's add functionality to this right away. Again, I told you that it always starts from the origin, but I want to visualize this. For example, let me go. I want to kind of move it here, so I would like to visualize this from here. So let's add an option to our extension to specify an origin. So I'm gonna have here XYZ, and I'm gonna have origin or origin, and by default it's going to be xyz 0, but I think we cannot actually have this, right? Again, we can go like this, use this option like that. If origin is null, we're going to say that that should be xyz 0. But what we can do right now is that now I'm going to show you the trick of how to move elements along some specific vector. So here we have a vector, right, again. So what I want to do is that I want to grab the origin var, let's go endpoint. Let's name this endpoint, always be descriptive. And I'm going to say that I have this origin and I can go plus, so we can add points with one another. And why we can do this is that if I go to documentation and I go XYZ class, here I have operators for the class. And we have addition, we have division, we can multiply them, we can subtract them, and we can do a lot of cool stuff with them, right? So it's a lot of cool features that you have here. To be honest, I haven't used all of them, right? But it's good to know that you have them. Not only you can use these operators, but for example, here you have a method add that pretty much does the same thing, right? It also adds, it kind of does this behind the scene. So what I want to have here is that I'm going to go origin, and I'm going to go like origin plus the vector, and that's it. So that is going to be my end point. So basically what I did actually here is that I have imagined that here you have a point and we simply go, for example, if your point was there and you're saying I want to add this here, and it's going to go like with addition, right? So it's going to go like here and just moves up, right? So that'll just move up. If I were to visualize it, it would be like move, it would be like this. So now I would actually move this here. There we go. That is the representation of this. Again, play around with this. It'll make more sense to you. But I'm gonna actually show in a lot of examples, I'm gonna show you the usage of this. So yeah. So now we have this origin. Also, you can specify like the length of this if you would like to kind of make it more, right? So for example, you can go scale if you want, right? You can go integer scale, and let's have by default one, and I can say maybe you don't want sometimes to do this, right? If you want to see the raw representation, but it just for you that you can do something like this. Now, I don't want to have it. I just showed you that you can do this. And now we can simply say that my start point will be origin and my endpoint will be endpoint. So let's see if I go here and I visualize this, but I want to have the origin. I want to get the location of my family. So here I'm going to have var location, family location. Let's name this like that, family location. I'm going to select elements, location. It's going to give me the location. I want to cast it to location point because location point inherits from location. So it's basically location, right? Because location has two classes that derive from it. It has a location per point and location curve. Because in Revit, we have elements that are point-based and curve-based. And from the location point, we can have a property point, and that will return the XYZ. Right now, it's telling me that it's possible null, so I'm going to go with this null forgiving option. So by putting an exclamation mark, I'm just saying that, you know what, I'm sure that it's not going to be null. And here I just can say that family location will be my origin. Let's see what it will do actually right now. Let's go back here a couple of times. Yeah, like this. So now I'm going to call this, select element, finish, and as you can see, it was placed there. So it shows us the kind of the movement of this. So yeah, now we kind of just got the basic of this, so it's actually a lot more to cover. So what I want to show you also is that like the first thing from this method that we have here is that you need to understand that to move points along a given vector, you just add them. For example, if you have a point like here, right? If you have a point there, and if you want to move this along a given vector, you simply go with this point plus vector. If you want to specify the distance, you just go with the multiply. For example, we have this. Let's go. So I think it would be better to just explore like all cool options that we have here because I think right now is that we have a lot of cool functions related to points. So it should be dedicated to another video. So we have this vector. Let's kind of try to move some points along a given vector so we can kind of play around with this. So we have this vector, right? And for the time being, I don't want to grab this location curve. I don't want to move this element right now. I just want to see this vector again, right? So and let's actually also visualize the point, right? So we can also go here and say visualize as point. I'm gonna copy this, I'm gonna paste it there, and I'm gonna say visualize as point. And here I don't want to have origin. Here I would name this just a point. And what I want here is that it's gonna be simply like this point. And I want to return even like I don't want to return anything because usually when I visualize, I don't want to see this line. And actually here we could have just passed leave a void, but okay. Actually, we should actually go like this. Point dot create because it waits for the geometry objects and XYZ is not a geometry object. We should create a point to make a geometry. Why I did this because I want to visualize vector and I also want to visualize the family location. So and maybe right now, right off the bat, we want to create an extension method for the elements. So if you want, you can do this. So create an extension method for the element to get location. So to not do this part tons of times. So I'm going to go family location, visualize as point document. Let's see what we will have in our model. So I'm going to run this. I'm going to select it, finish. There we go. We have a line, and here, if I hide it, we will see the location point. Let's say I want to move this location along this vector, right? Let's kind of do something like this. And I'm gonna go back, and what I'm gonna do is that I'm simply gonna go like this, var moved point. Let's be like this. And I want to say what point I want to move is the family location. And I go plus what vector I want to move it along, and that'll be vector. And let's leave this as that for the time being, right? And what I want to do here is that let's visualize this moved point so we can compare all of them. Moved point dot visualize as point, and let's just see this. Let's just see what that looks like, right? Now I can go back because I'm gonna recreate them. So let's quickly see this. And now you can see how Add-in Manager really comes into play because it's kind of quite powerful. So what happened? We've got this point and now we move that here. And now if I move this one here, you can see that that was moved exactly to this location. But now you may ask, but what if I want to change the distance of this? Again, it's no big deal. You just go vector and you multiply by some distance. Because what happens here is that your vector has a length. So let's kind of go with the task dialog here and show like message. I don't care right now. And let's go with the moved. I want to go vector get length. So that will show me get length. Here I just need to convert this to string because it expects a string here. So I just want to show you what it will give us. And that will give us the distance. It's actually in decimal fits, I think. Yeah. So yeah, if you want to check out if that is the case, you can do this. So 1.8, and let's say we want to change this. So I'm gonna have var new vector. It's a bad name, but let's gonna just do this. I'm gonna go vector multiply by 4, for example. What it's gonna do is that it's gonna take this vector and multiply by 4. So I'm gonna go with the plus new vector, and I want to visualize moved point, and now I want to visualize new vector. And okay, let's even display the length of the new vector. Let's go with main. It's gonna click it, finish, 7.2. As you can see, it was multiplied by 4. That is our vector right now. That is what it looks like. And if I move it, that is the distance where it was moved, right? As you can see how simple it is. So as you can see, it's not that complicated. So if you want to go to the different direction, you simply need to go with minus. So let's say that now let's kind of see how that would work, what kind of vector we get. For example, let's have this vector and let's create also a vector that goes here, right? So let's kind of visualize this right away. So I want to see how to multiply, like subtract vectors. So now you can see, you at least saw how we can move points along a given vector. Now I want to see more stuff with the vectors. Now I can actually remove this. I just want to see how we can interact to create more vectors with just addition, multiplication. So multiplication is just making our length bigger, right? So you can go with like this, or you can go and multiply. It's going to be the same thing, the same. Let's go with a different part. So I'm going to have this new vector, and let's go new xyz, and I'm gonna create 0 on the x. I want to have on the y like -1 and 0 on the z coordinate. And I'm gonna visualize this new vector, and I want to visualize the vector that we had there as line. Let's kind of see it. Okay, I forgot to put a column there. So let's kind of see them. We just kind of visualize them, but I still think I forgot to close off. Yeah, we need to each time select this element. As you can see, we've got this vector and we've got this one. And let's subtract this from this. Let's do this so we can see what happens here. So what I'm going to do is that I'm going to go var third, oops, gosh, third vector, and I'm gonna go like the vector that I had, like this one, vector minus new vector, and let's see what we will have. I'm gonna go Control D to copy a new line, and I'm gonna say third vector visualize as line, and let's gonna see what it will give us. Again, we need to select it. As you can see, it was like that. We've got this vector, and that its endpoint, that is here actually. And then we say, let's subtract from this vector to this distance. So if you want to see actually how that happened, it was like this. So we had this vector, then we said subtract this one, and that was like this. It's not that complicated if you really think about like this geometrically and trying to visualizing this with points. So it's really important for you to just have this tool and being able to just visualize it. And now you can play around with this and see how this interacts. Because this is why the geometry can be so difficult to grasp, because we cannot visualize that easily. But now you know how. So basically, the vector, again, to repeat everything, to reiterate, we kind of have these vectors, and they have only like they are representing as XYZ. And why? Because it's just one point, because the beginning of the vector is always from the beginning of the coordinate system. We can move points along a given vector, and I just showed you how. Also, we can go with different operations like adding, subtractions, multiplying, division, right? So multiplying is going to make the length bigger. Division is going to make it smaller. Uh, if I go with minus, right? So it went here. If I'm going to add this here, it's going to move it here, right? So let's go back and add quickly. So if I go not minus, but let's go with add, like I want to add them. Now I'm gonna add them. And there we go. Actually, we had this one. I think we had this vector, right? Or what I did, because I already we had vector, we added a new vector. Yeah, so basically it's what we've got. And actually it looks like this because it seems like we added to this one, right? And let's kind of see, because I think yeah, let's kind of show this again. Let's show without this part, without the third vector, so we can see, because that goes to minus. So actually, the previous one was a little bit different. Yeah, sorry, I'm just gonna show you without the third one. So these are our main ones, and let's kind of right now leave them as they are right now. And I'm not gonna visualize them. I'm just gonna go with the third one so we can see where it is. But now I really think that it should go down, because here we have like minus sign. Yeah, it was my mistake, my bad. So right now, if I go here, y is going to go down, because that with the minus sign, right? And when we use minus, it was like minus, and that gave us plus, right? So now that go down, that went down. But the main idea you got, right? So here, if I make this be, for example, 1, or I go here minus, because it goes like this vector minus this one, and that is negative, so eventually that went up, right? So if I go here and select this element and I go finish, it's just going to move up. So that is the main idea. So really think about what your vectors are, and now it's time for you to practice. Play around with this, have some different options, and it's not like we're not stopping here, because as you can see, we have a lot of cool things here. We have a normalized method, and what it will do, it will make your length equal to 1. So if you go to your vector and you say normalize, right, it's going to equal to 1. So if I go this third vector, for example, here, and I'm going to go normalize, and now I'm going to go visualize as line, is going to be, okay, I forgot to put this one, is going to equal to 1. Let's go main, like that. It's gonna, and now we can see this one. That is the line that was just created. So it equals to 1. So that is what is really for you to kind of understand that. Here we have some methods like normalize, which is gonna make our length equal to 1. We have all of this multiply, we have subtract. That is the same as these operators like divide and all of this stuff. Also, we can measure distance too, from one point to another point, right? So we can do this. We can negate. Negate means change the direction of the vector. So if the vector was going there, negate means now it's going to go here. So that is also quite a cool thing. So in the next lesson, we're going to cover cross product, dot product, because I think they're vitally important for us to make use of vectors, because these are like the most important topics to cover when it comes to analyzing elements and give and get actually vectors that we need. So this is what we're going to cover in the next lesson. But I think that's it for this one. So thank you guys for watching, right? I hope you enjoyed it, and if you find the content useful, please like this video, subscribe to the channel, leave some comments, and turn on notifications. And again, thank you for watching and have a nice day.